In this video, we'll talk about how to simplify radicals with variables. So I have a few examples for us to work through here. Let's check out the first one. We have the square root of 40, x to the fifth, y to the third. How can we simplify this radical? Well, it's worth noting that if there's not a number outside of this radical right here, we can just assume that it's a 2. So to simplify this radical, we first need to focus on the number, so 40. So what we can do here is something known as prime factorization. That's where we break down 40 into factors until we're only left with prime numbers. So if we want, we could break down 40 into 20 and 2. 2 is a prime, so we'll underline that. We can further break down 20 into, let's say, 10 and 2. 2 is a prime again, so there's another prime that we can underline. And then we can break down 10 into 5 and 2. And these are both prime numbers, so that means we're done with our prime factorization. Now, this 2 out here tells us that we're looking for groups of 2 of the same number that we can pull out. So notice that here's a 2 and here's a 2. So we could pull these 2's out in front of the radical. So I'll put it right here. But notice that this 5, it doesn't have another 5 that we can match it up with, and this 2 doesn't have another 2 that we can make a pair with. So the 5 and the 2 have to stay under the radical. Or in other words, 5 times 2, which is 10. So we'll keep 10 under the radical. All right, next we move on to the x. We have x to the fifth. So the trick here is we need to ask ourselves how many 2's will go into 5? Well, that would be 2. So what we can pull out is an x to the 2, or x squared. And what would be left over? Just 1, because 2 goes into 5 2 times with 1 left over. So whatever is left over, x to the 1, that has to stay under the radical. So we'll just write x, or if we wanted to, we could write x to the 1. We'll leave it as x. Lastly, we'll move on to this y. So we have y to the third. So we'll use the same trick. How many 2's can go into 3? Well, just 1. So we write y to the 1 on the outside of the radical. Or if we want, just leave it as y. And what's left over? Just a single y. So that y has to stay under the radical. So this is our final answer. This is how we can simplify the original radical. All right, let's try another example. Let's say we have the cube root of 54 x to the third, y to the fourth, z squared. How can we simplify this radical? Well, once again, we'll just start with the number, 54. We'll do prime factorization. So let's break this down into 2 and 27. 2 is a prime. 27 can be broken down into 9 times 3. 3 is a prime, so we'll underline it. 9 can further be broken down into 3 times 3. And these are both primes. So notice that the number on the outside of the radical is a 3 this time. So that means we're looking for groups of 3 that we can pull out. So here are 3 3's. We can pull all of these out on the outside of the radical. And notice that we're just left with a 2. So this 2 has to stay inside of the radical. So we'll write a 2 right here. All right, now we'll move on to the x's. So remember the trick. How many 3's will go into 3? Well, just 1, and there's nothing left over. So we are left with a x to the 1 that we can pull on the outside of this radical. Next, we'll move on to the y. How many 3's can go into 4? Well, just 1 with 1 left over. So we can pull 1 y out, and remember we have 1 y left over that has to stay inside the radical. And lastly, we'll say how many 3's can go into 2 right here for this z term. Well, 3 can't go into 2 at all. So this z squared just has to stay inside of the radical. There's nothing we can pull out. So here's our final answer. All right, let's try one more example. Let's say we have the fourth root of 16a squared, b to the fifth, c to the ninth. How can we simplify this radical? Well, we'll start by focusing on the 16. Let's factor this into 4 and 4. And each of these can then be factored into 2 times 2. So here's another 2 times 2. So these are all prime numbers, so we're done with our factorization. And remember, the 4 tells us that we're looking for groups of 4 that we can pull out. Well, notice that we have 4 2's right here. So we can pull this whole group of 2's out in front of the radical as a single 2. All right, next we'll move on to the a squared. Remember the trick that we used. How many 4's will go into 2? Well, 4 can't go into 2 at all. So this a squared has to stay inside of the radical. Next, we'll move on to the b. How many 4's will go into 5? Well, just 1 with 1 left over. So we're allowed to pull 1b on the outside of the radical. And remember, we have 1 left over, which has to stay inside the radical. And lastly, we'll move on to the c's. How many 4s will go into 9? Well, 2 4s will go into 9 with 1 left over. So we're allowed to pull 2 c's out, or in other words, c times c, so c squared. And we have 1 c left over that stays inside of the radical. So this is our final answer. This is how we can simplify this original radical. And this should actually have a 4 right here on the outside of this radical.